Welcome, wonderful people. This is Mr. Ndabezita, and we will be looking at declaring your own events and build handler events. So, this is very, very important. It is a topic that requires that we understand thoroughly what is happening, or we try at least to do things in the right way in which these things should be done. So, one most important thing that we have to do when dealing with this chapter is just to all right, so I was just saying to declare your own event, you use a delegate. So, this is very, very important. We are going to work once again with a delegate. So, but this time we are creating an event using what? Using a delegate. So let's continue with this. An event provides a way for the clients of a class to dictate methods that should execute when an event occurs. So there will be some events that will be occurring, and we want the methods that we have declared to be able, the delegate to be able to call the method event that we have passed into the delegate. So it is very important. Remember, in the previous two tutorials where we dealt with the delegate, we explained that they are able to make final decisions during runtime. So when this event occurs using a delegate, the delegate will be able to make the decisions during runtime. So therefore we are saying an event provides a way for the clients. These clients are the clients of a class. For example, in this class we have a few clients which we can call the fields. We can have an ID number, we can have the salary, we can have the address. These are what now? These are the clients that we want to keep track of. Whenever these clients, these fields, these members of a class changes, we want to be notified by an event that is declared using a delegate, because without a delegate this would be impossible. Hence they are saying now to declare your own events, you use a delegate. So a delegate plays a central part in this event that occurs, because the delegate will be the one that decides during runtime which method should execute. Hence, they are saying an event provides a way for the clients of a class to dictate methods that should execute when an event occurs. The clients identify methods to execute by associating. These clients identify the methods to execute by associating the delegate with the method that should execute when the event occurs. Very important, these fields that we want to keep track of, which we call the clients. Whenever there is a change that is happening, the client will identify a method that needs to execute. How? By associating the delegates with the method that should execute when the event occurs. This is something very similar. This explanation is very similar to the past two delegates that we dealt with, because remember, when we send in two objects that are a reference to a method, therefore during runtime the delegates decides which one should execute. This explanation sounds very familiar with the explanations that we had in the past two tutorials when we dealt with the delegates. Just like the event handlers that are automatically created in the IDE, each of your own event handler delegates requires two arguments. Very important. A delegate, the event handler delegate requires two arguments. This is a centrally important part. The event handler delegate requires two arguments. The first one is the object where the event was initiated, the sender. These are the two objects or the two parameters. The first one is an object where the event was initiated, where the event was the sender, the origin, the source, where this event was initiated, and the event argument, which is the destination, we can say. So we have the beginning, the sender, and the receiver. Very, very important. We have the sender and the receiver. This event handler delegates requires those two arguments, which are objects in this case, because we will be creating a class. Very important. And this class will reference, or this class will have methods that we need to reference whenever the event handler delegate is executed. But that is fine. That is fine. So they say now you can create an event argument object that contains information, or you can use the event argument class static field named empty, which represents an event that contains no event data. Okay, that was just a lengthy explanation as to what we are trying to explain there, but I will keep on repeating this whenever I am coding here. I will always just go and show you how all this works out. So the very first thing that we will do, that I always believe that we always do, is to create a class which we will call a student. We want to keep track of a student, right? This will be a student class, and one most important thing that we should know about this student class is what is the information that is contained inside of this student class. Now, the very first thing that we will have, which is very important inside of this class, is to declare first an event, a delegate. Now remember, the delegate has to be outside of the class but in the same namespace. So we dealt with this in the past two tutorials, so just go and check that for us. Please do not forget to like, share and subscribe so that you can get all the notifications whenever Papa Fanzo is busy with the console screen. Right, let me just say I have just this import using let me just say static system dot console. This one is very, very important. It is pivotal, it is central in our everyday coding. This console.writeLine is truly tiring. Right, the first thing that we will do whenever we are outside of the class but in the same namespace, we will try and create a delegate. This delegate will be public. We want to have access to this even when we are outside of this class. It will return void, and I will call this the changed event handler. This is very, very important, guys. I will call this delegate a changed event handler. And what will it do now? It will accept two arguments. And the two arguments that it will accept, why should it accept two arguments? Now let's go and check. Each of your own event handler delegates requires two arguments. The object where the event was initiated, the sender, and an event argument. Very, very important. So that is why this delegate that we are trying to create here must have two arguments. That is the reason why. Right, firstly, I will have an object. This delegate is going to receive an object, which I can just say, okay, let me give it a name, sender. And secondly, it will accept an event argument, which I will just call E. Remember, a delegate doesn't have curly braces. You just specify the number of parameters and then you enclose that with a semicolon. We know that. There's nothing new about that. Right, I am entering inside of a class, and there will be some few fields that I will have to declare inside of this class, because they are of significant importance. They are the ones that I want to keep track of. Unfortunately, we will just use 2 fields, and then we will just keep track of just only 2 fields, just to try and give us a basic as to how an event truly works. So the very first one, this is a student. So this student has a private int, which is the ID number, or we can just say the student number of this individual. It is private because you do not share that with anyone. Everything that you do not share with somebody is private. But nowadays we share even private stuff. That is why it is no longer safe anywhere. But with engineering, things remains behind the scenes. It is a pivotal principle that you hide the information. Right, so we will have this private double, which we will call the GPA of this student. Right, now it is very important where you declare your event. The event is always declared inside of a class. This is very important. Let me not say always. Let me qualify this. Not always, but in this case, in this tutorial that we are looking at, the event will be and must be declared inside of a class. Hi, Papa Fanzo. Right, let us continue with this. Now, this event will be public. We want to have access to this event even if when we are outside of this class. And I'm going to explain exactly what is happening here. So I will have public, and you use the reserved C# keyword, which is event, and then you give it the same name as the name of the delegate. Very important. It uses the same name as the name of a delegate, and then I just press tab there. So when we hover over this, or you press there, so this event and the object, this is an event. It has the same name as the name of a what now? A delegate. And then this is the object of the delegate. This thing looks very similar to declaring a field, because you will have maybe private static int ID number or private int ID number. And then look at this one, it is public. Instead of saying int or double, we use the C# reserved keyword event. It uses the same name as the name of the delegate, and then this is the object of this event, and then we call that object changed. This is the object. Now this object will be passed whenever an event is triggered. Very, very important. Now let us read some theory on this so that you may have a broader understanding. When you create an event arguments objects that contains event information, you can use the event argument class static field named empty. We will deal with that, which represent an event that contains no event data. In other words, when you use this static field named empty using the event argument.empty field, simply tells that it simply tells the client that an event has occurred, but without specifying the details. because it is empty. So there are no details that are provided. It just tells you that the event has occurred. Right. The identifier changed event handler can be any legal identifier you choose. So which one? This one. It's an identifier. Very, very important. We are therefore saying when you say public delegate void changed event handler, what is this now? This is just an identifier. So this identifier that we have, okay, that is fine. So what are we saying there? We are just simply saying now that this changed event handler is the identifier. So the identifier changed event handler can be any legal identifier you choose, but it has to be legal. It can be legal. So here we can just use any name. This is exactly what they are saying. So you can, but when you use that, for example, when I say S here, do you see what that does now? Look, when you hover over here, the type or namespace could not be found. You see? So it has to have, your event must have the same name as the identifier, which I also call the name of your delegate. This is very, very important. Okay, let us continue there. Right. This delegate defines a set of arguments that will be passed to the method that handles the event. This is true. We are passing in two arguments and they are both of type object. But this one is the built-in event handler and it's an object of that built-in. And this will be the object of the class that I will pass. So you can look at this as the sender and the receiver. This is one way of looking at this. You have the sender and you have the receiver. Very important. And your event has the same name as the name of your delegate. It has the same name as the name of the identifier. Very important. Very, very important. And look what is happening here. I want you to look at something. It is an identifier of type delegate void, and it also must accept two arguments. You see, object sender and the system.event. This one is the built-in event handler that will handle the event. So this is very, very important. So when you hover over this, it also accepts two arguments which are of type object, just as the delegate that you have declared here accepts two arguments. Very, very important. And what is this now? This is just an object that will reference to what now? That will reference to the delegate. Okay, that is fine. That is fine. Let us continue with this. The delegate changed event handler can be used in a client program that handles the event. Okay, that is fine. So we have inside here those two fields, and then one most important thing what I want to do there is to just have accessors, properties with accessors get and a set. So I know that they need to be public, and because the first one is of type int, therefore I'll have an int and I'll just say ID number. And then remember, this is a property, so I'll have a get that returns the private member, and I will have a set that set the ID number to the value that you assign to that. Very, very important. Let me just end the set block. Right. Immediately inside of this, let me show you something. immediately inside of this. When this when this property has been able to return and set that, whenever there is a change that happens to the ID number, I want to be notified of that. So before you exit the set block, you must have what now? This event that has to take place. But before it takes place here, let's go and create a method first. So let me go out of the set block, and then what I'm going to do there is to just have, okay, let me also have a public property which will be of type double for the GPA now. And let me have a get that will return the GPA, the private member. And let me have a set that will take the GPA that will be equals to the value that you assign. And immediately before you exit the set block, I'm going to pass in an event there. Alright, that is fine. So let me just end the set. No, yes, end set. And then here I just end the property. Very important. The spelling is not so much troublesome to me. So once I have created these two properties, okay, let me just go and create a method. Right, I will have this method as a private. The method will return void because the delegate returns void. So this method that I'm going to create here also has to return void because the delegate returns void. So the method also needs to return void so that it can match exactly the delegate. So this will be a private void, and I will call this method on changed. So whenever there is a change that is happening, this method will be called. That's why I want to insert this method inside of the set block of the ID number and the GPA. So whenever every time you are setting the GPA, every time you are setting the ID number, I want this method to be invoked. So this method, which is called onChanged, will accept a parameter, and it is a built-in event argument which I will call E. So it will receive an object, in other words. All right, that is fine. Let us continue with this. Right. And then what is it that I want to do here? I want you to hover over this and check. It represents the base class for classes that contains event data. Very important. It represents the base class, which is which one? This student class. It is the base class because it is the class that contains an event data. Very important. And it also provides a value to use for events that do not include event data. Okay, that is fine. So what I'm going to do here, I'm going to say changed. I'm going to say changed, and I'm going to pass in the first object, which is a reference, and then I'm going to pass in E. Let me show you something. Do I have any variable or anything that has this name changed? Let's check. Yes, I have it. There it is. Changed. And then what is this now? Right. Non-nullable event changed. It shouldn't be null. It must contain something. must contain a non-null value. Whenever you see the term null, it references to an object. It must have an object, because only when an object has nothing, it is null. So whenever you see a null value that references to an object, it has to contain an object. Very important. So must contain a non-null value when exiting the constructor. Jesus. So in other words, when it exits a constructor, it must have an object that it should reference to, an object that is stored inside of it. So I am creating a method which is called onChanged. Whenever there is a change that happens to the GPA or to the ID number, this method will be invoked. It accepts one argument. And what is this now? It accepts a destination. Please, this is not an argument from the sender. This is the destination, the built-in event argument object here. And then what am I doing now? This object, look, you see? So this object, what am I doing now? I am trying to create a link between those two. When you see that this class event handler dot student, you see it references to the student object. And this one, let me hover over this. E is not null here. It's a parameter. You see now? So it is an object parameter. And it is not null. Very, very important. E is not null here. So this is a parameter, the destination object here. And this one is the object of the student class. Very important, right? I don't have any other way of explaining this. Unfortunately, this is the best way in which I can try to explain that. Right, and then we can just end this method. Okay, so we are done here. We have understood exactly what is happening, or I have tried to explain what I think is happening. Right. So what we are going to do now, let me go here. Now the first thing that I want us to look at is just the fact that the class that we have contains fields that will hold the ID number and the grade point average. This is the GPA. It is just simply the grade point average for the student. We saw that, nothing it's new with this. Right. What is this now? Let us look here. What is this? What is this line? What does this line really does? Now, this shaded statement that I have just shaded for you there in the screen, it defines a third student class attribute. It just defines a third student class attribute. It defines an event named changed. This is the name of the event. The event name, this event, the name of this event is changed. The declaration for an event looks like a field. I've already explained that. But instead of being an int or a double, it is a changed event handler. Exactly. That's exactly what we have just said. The student class event changed. Very important. Looks like an ordinary field. However, you cannot assign values to the event as easily as you can to ordinary data fields. Even though this looks like a field, but it is not. It is an event, and you cannot assign values to the event just as you can assign values to normal everyday fields. Very important. You can only do two actions on an event. Which event? This event. There are only two things that you can do to this event. Very, very important. You can compose a new delegate onto this event using the plus equals operator. So you can add to an event, or you can use the minus equal operator. You can subtract to the event. And this is exactly what we will do. We are going to add to this event delegate. Events you cannot add ordinarily just as you are adding values to ordinary data fields. There is a way of adding to events by using the plus equals operator or the minus equal sign operator. And as we continue with this will become very clear. Alright, now remember we just created a method and we said that this method is unchanged. And I said I wanted to keep track of the ID number and the GPA immediately when there is a change that happens there. So immediately after you have set the value is equals to the ID number, then let's now invoke this method which we call unchanged. Now remember unchanged, this method, guys, remember this method accept a destination object, or it accept an object, it accepts a parameter of type object. So what am I going to change there? What am I going to send there? I am going to send an event, and it is a built-in, please do not forget, event argument and then dot, and then I'm going to say dot empty because this is just a what now? This looks like a property. It looks exactly like a property. So remember what we read about that. They said to us, in other words, using the event argument dot empty field, it looks like a field, sorry, not a property, a field. This is a field, simply tells the clients that an event has occurred. So when I invoke this method which accept what is this now? It's an object, but this is a built-in event argument E. So this object, which is a built-in event handler or something of that nature, when you say event argument dot empty, and then as you can see here, you are not just passing any object that you want. This is not an object that comes from the class. This is the built-in event object. Hence, even here, it must accept this built-in. It accepts a built-in object. So when I am here, I am sending that built-in dot empty, and this tells me that the event has occurred. Very important. And I will just copy this and I will just paste inside of this one. Right. So once that has been done, and as you can see that we do not have any errors on that because we have done things in the correct way. Now I want us to do something here. I want us to go and do something. Right. I want us to have a second class. I want us to add a new item that we will call a class. So here we are, guys. I have just created, let me just end the class and end the namespace. All right, let me just do this. All right, so we have just created a class. There it is. So okay, let me just change the name of this class. You just come here and you say rename, and then we will call this the event listener. So this will be the event listener. All right. Okay, let us continue in this. So what is this event listener that we are trying to create? Let me just read for you what that is. Right, event listener class that listens for a student event. So this class let's say listening to a student event. So this class is an event listener that listens to a student event. That's exactly what it is. Okay, that is fine. Now, what are we going to do inside of this event listener? We are going to have a private, and it will accept a student object, and we will call this stu. So what does that really means? We can see that this class, it contains a student object that is assigned a value using okay, we have not yet dealt with parameters. Let's leave that. So this is just a class that contains a student object that is assigned a value, right? So but we have not yet assigned that a value, so let's just leave that. So what will be this now? This is the object of the student class. So let's just take that. This is just an object of a student class. All right, and then what is it that we want to do there? We just want to say, all right, let me create a constructor. I think a constructor might be very, very helpful in this regard. So I just have this private student, what now, object on student class. So inside of this event listener, I'm having a what now, an object of the student class. This is just what I have there. So let me just create a constructor of this event listener. And what will be the function of this constructor? So this constructor will accept an object which is a student, and I will just call that a student. So what is this? This is a constructor. It is a constructor of this class. We dealt with this, nothing mysterious. And what does this constructor accept? It accepts what now? An object of type student. It must be an object that comes from the student class. So when you create, when you instantiate a student, then when you invoke this class here, when you invoke this class, when you create an object of this class, you must send an object of what now? Of a type, which is a type of a student object. I'm trying to explain this. I'm trying so much. So now that I have an object of the student, I'm gonna just say stu, and then when you press the dot here, you see what you have access to, the method inside of the student class, which is changed, and you have access to the public fields and properties and everything that is public that comes from that class. So what I'm going to do, remember, to an event delegate, we can only add or subtract to that. That's how we can add or subtract to that. So as a belief, we cannot assign values to an event like we do to ordinary data fields. So we must add or remove to that using the plus equal or the minus equal operator. So I'm going to call this method. And what am I going to do? I'm going to add to that. And then you know that what the new does, it reserves memory. And then what am I going to say? I'm going to say changed event handler. But when you know that changed event handler, what is that? The changed event handler, it's the name of the delegate. So when we invoke this method does what now? This method, please be careful. I am not here. Where am I? I am here. Because I'm invoking this method on changed. This is exactly what I am invoking. And then now look what is happening. On changed. On changed does what now? It accepts one argument, the destination. So please, I'm not here. I am referring, remember I invoked just this method and it accepts only one argument of type event. Event argument which is of type object. It accepts a built-in destination object called E. So when I am inside here, and then when you make the brackets like this, you see the target. It accepts, it is looking for a target. And look, it must be an object. Which object will this be? It must be an object event argument. So let's try to see how this will work out. So I'm going to send a student changed. So I'm just going to send student changed. Now there's a problem here. There's no method of this nature. So before I send this, let me just go and create a method that will be able to have this name. So let me just quickly go out of this constructor and let me have just a private void, and I will call that student changed. Let me just copy this and just paste. Right, what will it accept? This student changed. Let's hover over here. Okay, nothing, it's wrong with that. So the first one, look what is happening here. Guys, let me show you something. When I'm here, look what is happening here. It is looking for two parameters, the sender and the target, the destination. So when I invoke this method here, and I'm reserving memory for that, it is looking for two objects here. It must accept, the first one is the sender, the second one is the destination. So this method, if I'm going to send this method inside there, it must be able to provide those two needy things. And the first one is the object, which I will call a sender, and the second one is the built-in, it is the event argument, the destination, which I will just call E. What does this method do? The method simply has a write line. Let me come here, copy this just on top of your namespace, and then you just paste. So let me go to this one, let me just paste. Right, so what I will do there, I'll just have a write line, and in this write line all I'm just saying is that the student changed. And that's all. I'm just saying the student, let me just say, has changed. And then let me have a write line once again, and I'm going to just have some space and just say ID hashtag ID 0, and then have the GPA, and then GPA, and then just have a 1 there, and then I'm going to say stu, because all these things are inside of this object class, and then stu dot GPA. That's all. So I am telling you, if ever the ID number has changed, it will tell me. Whenever the GPA changes, it will also tell me. And remember, I am accessing these things via a public property with accessors get and set. Right, so this is all what I'm doing. So this method, because when I say new changed event handler, because the changed on changed. So when you come here and it say changed plus equal, so we need to go and look at that method. Where is that method? Changed. It's not a method. What is this now? This is not a method. This is the name of the event. So when you call this event changed in here, you are adding. We can only add to the event or subtract. So we are having this event name, and we can only add to that. So when you add like this and you say new, and you now say changed event handler, now which one will it point to? This one that accepts two arguments, the sender and the destination, because it uses the same name as the name of the delegate. Okay, that is fine. So let me just pass in or send in this method, which I call the student changed. Now everything is fine for all the reasons that I have provided to you guys. All right, be that as it may, let's now go to the main. So when we are in the main, the very first thing that we need to do there is to create an object of the student. Student, let me call this one student equals new student. And when I do this, I don't have a constructor of students that accept anything, so the default one will be provided for me. All right, and now I want to create an object of the event listener class. Remember, I have a class which is event listener, and I will call this just a listener, and this is equals to new event listener. And then when you do this now, it accepts what now? It accepts a student object. It accepts an object that has been created from the student class, which is one stu. I Jesus, my Father and my God. Let us continue with this. So let me just quickly assign values. So I'm going to say one stu dot. Let me start first with ID number and just say 2 3 4 5 1 stu dot. Let me have another ID number. And let me just say 4 5 6 7, and let me just have one stu dot GPA and assign it a value of 3.2, and then let's run this and check. Right, let us just try to run this. Okay, there was an unhandled exception. Line 15. Line 15. Let me check. Okay, let me run this and just check exactly what is happening here. Unhandled system.null reference exception object reference not set on an instance of an object. All right, let me just do this just to get more information. Student in this event handler event listener.cs. You see event listener.cs line 15, event listener.cs line 50. All right, let us check where the problem might have risen in there, because I think we created that class and then we said stu. Okay, let me hover over this, maybe null here. Okay, so let me just quickly fix that. Before I can add, I cannot add to something that is null. So all I have to do is just to say stu equals the student. Student. This one. I am sending this one there. So I'm saying take this object and assign this object to this object of the student. So because we dealt with exception handling, I am able to see where the error is. And remember, what was that? That was the stack flow. The stack flow gives you a detailed, clear description of where the error might have occurred. If the error occurred either in the event listener class, it will tell you exactly that. Jesus, I love this, man. Let us run our code and see whether everything will run fine. Now everything is running fine, and unfortunately I'm not going to explain why the code is the way in which it is. I will explain in the next tutorial. Thank you so much for watching.